Bonjour tout le monde. Donc, bienvenue à cette session sur les transports et la logistique. Je vous rappelle que vous pouvez poser des questions directement dans le chat, mais le chat sur l'onglet questions. Posez-les le plus tôt possible parce qu'on peut effectivement les prendre à temps avant que la communication coupe après 25 minutes. Donc, je suis content de vous présenter notre prochain invité, M. Hyuntae Jung de IATA. La présentation s'intitule Collaborative ML Development for Proactive Risk Identification in Global Aviation. So our next presentation, please welcome Mr. Hyuntae Jung from IATA. Mr. Jung is a data scientist in global aviation data management at International Air Transportation Association, IATA. He is specialized in aviation safety and air traffic management, data analytics, modeling, simulation, and optimization, including machine learning and AI techniques. He has been leading collaborative R&D projects between IATA, IVADO, and University of Montreal. He was implementing data science model in aviation safety risk identification. So, Mr. Jung, the floor is now yours.
Thank you very much. Good morning, everyone. As I said, my name is Hyuntae Jung, and I work in a global aviation data management team in IATA. It's my great pleasure to present the ongoing collaborative machine learning research and development projects under the Data Science Initiative in IATA in today's IVADO Digital Intelligence Day. Okay, so first, I would like to briefly introduce about IATA. IATA, the International Air Transport Association, is the global trade association representing around 290 passenger and cargo airlines around the globe, representing 82% of the global air traffic. Our mission is to represent, lead, and serve the airline industry. IATA works together to shape the future of growth of safe, secure, and sustainable air transport industry that connects our world. Global Aviation Data Management is IATA's safety data and analytics program, including accidents, incident, and flight database, serving the industry as trusted data custodian for global safety data since 2003. The aviation industry connects people, markets, and cultures around the world, influencing the economic, social, and political landscape of countries. The aviation industry supports 65.5 million jobs worldwide and facilitating international supply chain and business. To ensure that the air transport industry continues to play a major role in the global economy, safety has been established as one of the primary goals in the industry. With the continuous and collaborative efforts from a global aviation community, the air transportation is one of the safest means of transportation. The figure shows the decreasing trend of accidents over 15 years. However, it is still important to continue this work to ensure every flight even safer, as aviation safety is one of the vitality for sustainable growth of aviation industry. To continuously enhance safety performance, safety data and information plays a key role to identify existing safety risks and develop actionable insights. Safety data and information such as the accidents or the incidents, reports, and flight data can be analyzed to identify and assess the operational risk and support necessary actions. This data-driven safety risk management process is one of the core components of safety management system. Well, therefore, reading and understanding the right data in the right time are the key to continue improving aviation safety, earning the industry the license to grow. Well, however, the visible major accidents are only the tip of the iceberg. To fully understand the underlying root cause or contributing factors, it is very important to detect potentially hazardous conditions, which may lead to catastrophic results if not handled appropriately. However, in the real operations, such underlying risk are the complex interaction between human, machine, and other environmental factors. To make this matter even more challenging, these factors are sometimes represented in inconsistent, subjective, and hidden in the pile of unstructured data. Well, such complexity and visibility are the major challenge of the nature of the safety data, and sometimes even beyond human capability. So with such limitation, data science or artificial intelligence techniques will be playing the key role of supporting the data-driven decision-making process. Well, currently the demand to assess collected data mostly start from a human observation or hazard. Analyzing each data set, integrating into meaningful insight requires lots of efforts and time, while it's very important to present valid insight at the right time for proactive safety management. We believe that data science, machine learning, and artificial intelligence techniques can automate this safety data analytics process that enables the data-driven decision-making effectively and efficiently. Here, I want to give some of the examples that ongoing data analytics program in IATA. The first example that I show here is the accident and incident data. When there are any safety issue during the operation, depending on its magnitude, either official investigation is performed or it could be just a crew reporting encountered issues voluntarily into anonymous written reports. The statistics over this control data is visualized and shared to the data contributor so that operator can identify safety issues globally and benchmark their reports within other similar cases. Another example is flight data analytics. Several airlines already have capability to analyze the aircraft state parameters collected during previous flights, known as FOCA or FDM program. FOCA stands for Flight Operation Quality Assurance, or FDM stands for Flight Data Monitoring. Well, GADM supports flight data exchange program, where the member operator can share their flight to the benchmark against global data. By comparing the global and regional trends, the operator can evaluate their status with better visibilities. Well, however, these two programs are limited into data visualization level, which means that the deeper interpretation of such visuals, prediction, or deriving recommended actions are still relying on the users. Although the data visualization is a very excellent tool to support intuitive understandings of the current situation for the human, however, as presented earlier, the ultimate objective is to achieve proactive safety and security management, where the in-depth, automated, and real-time risk identification is required. So to answer these requirements, the core question would be how to make a good findings over the right data at the right time. And here we believe that evolving towards machine learning or AI will be the solution. So IATA GADM has started the data science project from year 2020 to develop and implement the data science and machine learning technologies to support safety analysis, which ultimately aims to improve analytic capabilities so that we are discovering wider and deeper insight efficiently and effectively. To achieve this, the project aims to improve data capacity and coverage, deepen analytic capabilities, discover synergies between data sharing program, and stimulate sharing of innovative ideas. Starting from year 2020, IATA is working with IVADO and universities, well known for cutting-edge machine learning capabilities. We conducted 2 R&D projects last year. The first one is natural language processor application for incident report analysis to automate the data standardization process. And second, the correlative flight parameter analysis to identify and evaluate the hidden patterns in the flight data associated with certain risk. This year, we're now focusing on building an anomaly detection model over the GADM data portfolio. So these R&D projects aims to achieve tangible outcome and implement the model into IATA data management process. Well, moreover, IATA, we're very interested in collaborating with other industry partners because we believe that aviation safety is a common goal of the industry, while due to the complexity of the safety risk, taking a various data as input is necessary to capture more complete picture. So which is again is critical to reduce the risk of bias in the output to generate trustworthy insights. So with the support from IVADO, actually it's led by IVADO, IATA has been engaging with common interests in aviation group, sharing the best practice and share success stories in implementing the data science and artificial intelligence technologies with the companies from aviation domain. We are very open to more collaboration opportunities. So if you're interested in know more about our initiative, you can reach out to IATA GADM or and ask for detailed information. So from the next slide, I'm going to talk about some of the examples that are in how the R&D project went. So one of our example for R&D project is a machine learning application for smarter aviation safety report analysis. GADM has millions of safety risk, millions of the aviation safety reports written by pilots, cabin crew, engineers, or other personnel when they encounter with any risk that needs to be reported. This data set, collected from hundreds of the airlines, are bringing a huge challenge in cleaning and analyzing in a global scale. This written text contains unstructured, subjective, and incomplete information, and manually reviewing and cleaning this would be simply impossible. So we launched this project to develop the NLP model to automatically analyze the reports and then classify into IATA safety incident taxonomy. By automating an unstructured data process, we expect to save time and manual effort that enables teams to handle more data, releasing our resource to focus on the risk identification rather than data cleaning. So with the success of the first step, we're currently working on expanding these use cases into such as entity recognition, de-identification, and so on. The next example is the machine learning application for in-depth flight data analysis. Flight data, on the other hand, is a very extensive time series aircraft state parameters, such as altitude, airspeed, or engine parameters. So our typical analysis really focuses on the eventful flight when the flight has encountered any safety events. However, as illustrated earlier, those kind of eventful flights are just the tip of the iceberg. To fully understand what is going on beneath the surface, the model is helping us to identify the complex and hidden interaction of multiple features, which are correlated to events. The projects can help us to discover the distinct difference between the flight with events and flight with no events. So this correlation enables flight data analysts to identify the features and their links, which are the most contributing to the event, and evaluate the quantified weights of the contributing factors by airports, aircraft type, altitude, and other variables. And so that is, we are gaining the visibility at the lowest level of details. Potentially discovering some of the precursor patterns if possible. So again, with this success, we are currently working on expand this model into anomaly detection, which is automatically monitor the features from a collective flight data set and raise a flag if there's any anomalous patterns that requires human attention. As a conclusion, I would like to summarize the presentation and our ambition in data science AI. IATA is an international representative of the airline industry. Our main activity include supporting R&D projects and the global collaborations, encouraging the development and distribution of open source model and implementation guidance, discovering new opportunities and share the success stories among industry, and utilizing the full potential of AI into critical problems, leading in the AI era in aviation. Our goal is to represent, lead, and serve the airline industry. In the data science and artificial intelligence area, we envision to foster the collaborative ecosystem in the data science among airlines and industry partners. That leads the industry to derive innovative solutions for global aviation safety and security, which ultimately generates the value of public good. And we know that this is a long way ahead and we cannot achieve this goal alone. That's why this is the main reason why we are looking for someone to collaborate for the common goal of aviation safety. So as you see, most of the presentation materials are designed for the very high level illustration of what we do and why we do this. But if you have any questions, even if it's a technical, I'm really more than happy to answer any of the question you have. Thank you very much for your attention. If you have any other questions or comments, feel free to submit a question here, or you are always more than welcome to reach out to us for more details. Thank you.
Thank you very much, Mr. Jung. Very interesting. So as everyone heard, there's interest for answering technical questions. Maybe I would start, but with a larger scope question and about collaboration and innovation. What, in your ideas, are the best ingredients for a successful collaboration? What are the main components of a collaboration?
Of course, the collaboration, we should have a common goal, and sometimes the common goal especially when it comes to contribution, because each of the collaborator inputs their own resource, for example, their time, their effort, and for example, their data. It's really important to set the common goal that all of the collaborators can agree, because sometimes in the competitive markets, just like aviation, it's very natural to expect that each of the organization have a different idea of their interest. Well, and that makes aviation safety a little bit very special, because aviation safety is non-competitive. It's by its nature, it tends to be very collaborative, because you cannot be safe if only the airlines are operating safe, because it is a collaboration. The aircraft should be safe. It should be also involving with the airport or air traffic control. So so again, by framing the right question will be the key. And I think the aviation safety topic is actually quite comfortable when setting up this successful collaboration.
Yeah, it makes a lot of sense, since the safety is a key issue. It's above everyone's head, and it's very important for all the companies. Did you find at any moment an obstacle when it comes to sharing data? For example, I mean, you have your audio tapes. If you want to derive NLP models, did you have problems, issues with that?
Absolutely. The safety risks are sometimes pointing at some issues, and sometimes it's not always be very comfortable about this part, because although there's lots of regulations, and national regulators are ensuring that this voluntary safety is only used for the safety improvement purpose only, but still there's some concerns regarding to the operator, because they're not sure what happens if this sensitive data goes to public, and it is really like we can all understand this concern. So sharing this data involving lots of sensitivity, and so some of the collaboration effort we're trying to do is sometimes not going to wait to expose the raw data. What we're right now interested is to utilize the knowledge transfer model. So when we are building, for example, the natural language processing model, we can pre-train the model based on each contributor's data, and then transfer such knowledge for each specific case when the sensitive data is jumping in, because the publicly data is very small. But by framing this approach in a smart way, we think we can overcome this situation.
Interesting. And did you have at any point came to a situation where sensitive data could not be shared by the company? For example, because riskier events are very rare by definition, and
yes,
glad about that, of course. But it makes it difficult for you to identify patterns, to derive situation, to be able to make a decision system or an alert system. So is it difficult to get these rare events and to put them into the model?
Absolutely. You got it correct, because the accident we're looking at for the accidents is gladfully, it's very rare. We're not having a lot of accidents or the plane crashing down. So accidents is a very kind of rare, and it's like a one data points or no for a certain year, which is which building the data-driven model over this kind of scarce data is kind of really challenging because we're not sure that this is a common patterns that can be observed in the global. So that's the reason we're inviting incidents, which is which we can think of near miss accidents or not even incidents, such as like any kind of the existing safety risk, which risk is not evolved or resulted action such as incident or accident, but could be leads to the event if not handled properly. So as I presented earlier, our goal is to look under the surface. So that's the reason that we're putting a lot of effort to build the relation of the accident, incident, and the risk, and identifying these patterns to build what should I say, some of those like a complex interactions somehow represented in the data-driven way, so that we can, even though accidents are very rare, we can assume that what is very likely to happen for this case, because we saw lots of near miss cases happening in this way.
I'm very curious also for maybe more personal questions, but maybe it's raised to you all the time. We talk about autonomous cars, autonomous vehicles a lot, autonomous trains, and there's already autonomous trains and all over the world, but is there a place for that in aviation, or is it something that will never exist, or is it something that already exists and we're not aware of?
Well, actually, aviation used to be a leading industry in the autonomous. You heard of autopilots, and that technology was even existing several decades ago. So aviation by its nature, we're living with this autonomous technologies, and we are now in the tipping moments where we are now looking the future. This autonomous aerial vehicle or unmanned traffic system or urban air mobility is jumping in the aviation industry. So as I am affiliated in the safety department, it is a little bit hard to say that what exactly this autonomous vehicle will impact the existing safety system, but it should be ensured that this kind of new players, although they are bringing a lot of really innovation and new views world to the industry, is the impact for existing operations should be really like managed. So it's a really difficult question because I think everyone has his own personal opinion, but we're not able to make it more agreed upon that what is going to happen exactly. But I should say that it will gonna happen, and we know that we are kind of evolving slowly towards that way. I'm sorry that I couldn't give a really good answer, but that's the best I can do.
There's no bad answer. There's only hard questions, but thank you very much. Maybe there's 50 seconds left on the clock, so I will take this occasion to ask you, what impact did the collaborative research had on your organization, on your projects so far?
So far, our project is kind of it's not in a big scale. As I said, we last year we just did the 2 small projects, and with this success, we are trying to expand it to others. The collaboration so far is not really like impacted because we've been only playing with our data, but I think it's the right time because we have some result, and we're open to share it to the other industry members if they're interested. For example, NLP, our ultimate goal is to make it as an open source so that not only IATA get benefit out of it, but we are returning to all back into the airlines. If they're interested in adopting our model, they're more than welcome to do that.